Hi everybody, so you should have your 7.8 day 2 notes in front of you, and we're going to start with the conjugate of a complex number. Now the complex number a plus bi is in standard form, and we want to write the conjugate of that, which is a minus bi. And we're going to use the conjugate of that complex number to eliminate the I, our imaginary number. So to do that, it's sort of like you saw before when you were rationalizing the denominator, we multiplied by the conjugate. So the conjugate of, let's say, a plus bi is a minus bi. So in this form, the conjugate of 1 minus 2i is 1 plus 2i. So we're going to multiply the numerator and the denominator by the conjugate 1 plus 2i. Okay, so we're going to go ahead and distribute that numerator just like we normally would. 10 times 1, which is 10, and then 10 times 2i, which is 20i. And then our denominator, we actually have this quantity 1 minus 2i multiplied by the conjugate 1 plus 2i. When we multiply that, the product actually ends up being a real number. So, for example, when we multiply or FOIL this, we're going to get 1 times 1, which is 1, 1 times 2i, which is plus 2i, negative 2i times 1 is negative 2i, and then negative 2i times 2i is negative 4i squared. Now, in the numerator, we have our numerator already in standard form, so we're just going to go ahead and rewrite that the same way. However, in our denominator, you see that we have an I squared, and I squared is really negative 1, so negative 1 times negative 4 turns this to a positive 4. So we really have 1, and then if you look, we have positive 2i minus 2i, which cancel each other out, and we're left with 1 plus 4. So if we go ahead and simplify this even more, we have 10 plus 20i all over 5. And from this point on, we are actually not done, because if you recall, this is our complex number system, so we actually have a real part and an imaginary part. And in standard form, we have to make sure that we write our final answer in standard form as well, our real first, then our imaginary. So from this step, what we're going to do is we're going to take our denominator and divide it by each term in the numerator. So we have 10 divided by 5 plus 20i divided by 5, which simplifies to 2 plus 4i. And this is in standard form, so that's our final answer. So if we look at h, again, our point is trying to eliminate the value of I, so we're like making our denominator real. Right now our denominator is imaginary. So you actually have two choices. You could have just multiplied top and bottom by the imaginary part, or we could multiply top and bottom by the conjugate. So the conjugate of a complex number positive 2i is multiplying numerator and denominator by negative 2i. So again, we are multiplying the whole entire quantity in the numerator by negative 2i. So we have negative 3 times negative 2i, which is positive 6i. We have negative 6i times negative 2i, which is positive 12i squared in the numerator. And in the denominator, we have 2i times negative 2i, which is negative 4i squared. Please don't forget that I squared is negative 1. So it's like we have 12 times negative 1. And in the denominator, we have negative 4 times, again, I squared is negative 1. So what happens then, in the numerator, we actually have negative 12, and then we have positive 4 in the denominator. From this point, our denominator is real. We're good. However, we have to make sure this is in standard form. So if we rewrite our numerator so that it's in standard form, now we have to separate those terms, so we separate our real and our complex part, imaginary part. So we have negative 12 divided by 4 plus 6i divided by 4, which again, if you simplify this, becomes negative 3 plus 3/2 I. Okay, so there are those examples. Our last and final example is 2 plus I divided by 3 plus 3I. So the conjugate of 3 plus 3I is 3 minus 3I. So we are going to go ahead and multiply numerator and denominator by the conjugate, 3 minus 3I. Again, you're multiplying the entire quantity, top and bottom, by that conjugate. So we are going to go ahead and distribute thoroughly. So 2 times 3 is 6. 2 times negative 3I is negative 6I. I times 3 is positive 3I. And I times negative 3I is negative 3I squared. We're going to simplify that in a little bit. In our denominator, 3 plus 3I times the quantity 3 minus 3I. Again, since they almost look like a difference of two squares, we know we're going to end up with the form a squared plus b squared, getting rid of our linear terms per se. So we're going to end up with 9 minus 9i plus 9i, and then minus 9i squared. Our two middle terms here eliminate. Okay, so let's go ahead and simplify this. This again is negative 1, but negative 1 times negative 3 is positive 3. So we really, again, if we simplify our middle terms here, we have 6 minus 3i plus 3 all over. This is negative 1, but negative 1 times negative 9 is positive 9. So we have 9 plus 9 in our denominator. And again, if we go ahead and take this further step, we're going to combine our real terms here, which are 6 plus 3, which is 9, and then minus 3i. We have our numerator in standard form, divided by our denominator of 18. Again, from this point, we have to separate real from imaginary parts. So if we go ahead, we're going to go ahead and take each of those terms and divide them separately by our denominator of 18 and simplify each. So we have 1/2 minus 1/6 I. And there you go. If you have any questions, feel free to see me on the homework. Thanks.